Welcome everyone. Feel free to say hi. I hope you're all having a good weekend and everyone's keeping well. Do let me know if you can hear me. Feel free to say hi in the chat. I've got that open, so I'll be able to read your comments, messages, any questions you've got once we get started. So welcome if you're just joining. We've got a session today planned on an A-level topic that's part of the statistics side of the course. And it kind of overlaps with some ideas you might have met at GCSE before. It'd be great to hear from you all. So throughout the session, if you want to say hello, if you want to ask questions, answer questions as we go, this is a really nice one to look at. So this is part of the statistics content on the A-level. We're going to look at cumulative frequency and box plots as a way of representing data. So welcome if you've just joined. Hi to anyone that's, I think a couple of people have just joined now. Feel free to say hi in the chat if you can. And also as we go, if you want to share answers and comments, that'd be great. It'd be great to hear from you all. So I've got the chat open. As I said, it'd be lovely to hear from you. Welcome and thanks to those that have joined really promptly. I'm going to get sharing the screen shortly so we can get started. But I hope you're all having a good weekend. And we're kind of well into the school term now, so I hope everyone's getting on okay with that. As I said, do feel free to say hello, and I'd love questions and answers to come in throughout the session. So if you've got any questions as we go, do let me know. Also let me know if this topic is revision or if this is the first time you're seeing it. As I sort of mentioned, I think we'll be fairly familiar with some of the ideas from GCSE. So we'll get started, but welcome to anyone that's just joined now. I'm just about to share what we've got planned. So hopefully, let me just check. That's sharing. Let's have a little look. Hopefully you guys can see this. And we're about to start. So welcome. Thanks to those joining. We're looking at cumulative frequency graphs and box plots today. It'd be lovely to hear from you in the chat. We're going to get cracking. So thanks to those that have joined so quickly. Now, what we're going to look at today, first of all, quick thing about me. I'm the lead maths teacher at Snap Revise, and I did a maths degree a few years ago, and I've been teaching A-level maths since then. So yeah, it's been a good, interesting time to teach the A-level as it changed, and also there's been a lot of changes in the last couple of years. So yeah, it's been an interesting time. But a lot of the maths content there is quite standard from how it has been for a long time. So we're going to look at the specifics of the course. And this topic today is a really nice one to break down and look at with you. So we're going to be looking at cumulative frequency when handling group data. And we're going to use cumulative frequency graphs, looking at percentiles and group data, and then drawing box plots from this, and also look at exam style questions and how it would come up in the exam, what sort of marks it will be worth. Do let me know if this is something you've seen. Hopefully those of you that have started the statistics side of the A-level course have seen this. We're not going to specifically go into linear interpolation today, although interpolation is a skill that goes hand in hand with this topic. So let me know if it's new to you or if you've covered it before. Otherwise we'll get cracking straight away. So welcome, as I said, thanks to those that have just joined. Just as a quick recap of things we should already know when dealing with data, some kind of keywords and ideas and how we would deal with this list of data here. So in this list of data, we've got 9 different things, 9 different bits of information. So if we think of n being equal to 9, then the median, hopefully we're happy that the middle value, if it's an ordered list, will be the n plus 1 term and over 2. So basically add up the total. So there's 9 things, add 1 to it, and then half it. So this is a little bit strange, and this is a point of confusion for a lot of students at A-level. When it's a set number of things, a set number of items, a lot of people think we'll just divide it by 2, and that's the middle. But what we have to remember when it's a fixed number like that, we have to add 1 and half that. So that's the way I would generally teach it. And we'll see how it works here. If we do n plus 1, that would be 10. 10 divided by 2. So let's do that. So 9 plus 1 over 2. So that's telling us we want the 5th term. And in this case, that would equal 7. Now to sense check it, there's 4 values on either side. So it makes sense that 7 is in the middle. But this, don't think, if you think this is great, this is fine, I'm happy with this, brilliant. This is a point that a lot of people trip up on at A level as well. So we do have to be careful. And the same is true for the quartiles. So the quartiles, we're splitting the data into 4 kind of chunks. So what we're going to do here is the same sort of idea. We're going to do n plus 1 over 4. And in this case, again, we can sense check it. But if we do 9 plus 1 over 4, that tells us the 2.5th term, which in this case is between here and here. So we kind of average 3 and 6 out. So we do 3 plus 6 over 2, and that would be 4.5. So the lower quartile that slots in between 3 and 6 would be the number 4.5. And in a similar way, the upper quartile is going to be here. So this will be the 7.5th value. So it's 3 lots of n plus 1 over 4. So that's the term number we want. Who has seen this before? Hopefully this is just a recap. So this is, in this case, this would be 10, because it would be between 9 and 11. So there we go. And then what we can see visually is that the data is in fact split into 4 chunks if we do that. 2 values lower quartile, 2 values median, 2 values upper quartile, and so on. Brilliant. Right. So then in terms of percentiles, which is where we're going today, it's a very similar idea, except that it's out of 100. So we do the same sort of thing. So if we wanted the 10th percentile, we kind of want 10% through the list. So n plus 1 would be 9 plus 1 over 100, 10 times 10. So 10 times 10, 100. So that is 1. So it's 10 mass, it's the first term. And if we sense check it, the first term would be a 10th percentile. It would be a 10th, kind of a 10th of the way through. Okay, so it's a little bit weirder depending on the number in the list, but we're going to explore this today really carefully. So percentiles might be new from GCSE, but you hopefully have heard of quartiles and seen them before. And then a box and whisker plot, or a box plot, just as a quick reminder, this is the minimum value. So it is important we know kind of key bits of data. And in your exam, things could be presented in this way, or you could be asked to draw a box plot. But once we've got those values, we know the lowest value is 1. The highest value in this list is 15. And we know some key sort of points now. So we know that the first quartile is here. The median or second quartile is here. Oh, welcome. Excellent. Sorry, I'm just kind of seeing the messages in the chat now. So thank you to those joining and commenting and saying hello and asking questions. Brilliant. So well done if you recognize these parts of the box plot. Very good. That's great. So this hopefully is a bit of a recap, but what we're going to do is look at it in an A-level style setting now. So this part of the course, I'm going to just move on. Very well done. We are going to be looking at this kind of data presentation, which will come up across any exam board that you're working on your A-level with. This is such a key part of the statistics content. So in terms of cumulative frequency, we're going to start with an example of this. So cumulative frequency for a set of group data is, does anyone know what this is? So what is cumulative frequency? It's kind of a very key term that you've probably seen at GCSE. So the cumulative frequency for a set of grouped data is basically a running total. So it's a running total specifically. Yes, exactly. Well done in the comments there. It's kind of adding up as you go along. A running total of specifically, very well done, those suggesting that in the chat. Thank you for the comments. A running total of the frequency specifically. So you're kind of keeping tabs on how much frequency has been added. So the running total of the frequency up to and including that set. And sometimes it's just easier to see an example. So that's what we're going to do. So a running total of the frequency up to and including that set. So for example, we've got some group data here. So X could be between 0 and 1. There's 25 values in that interval. Between 1 and 2, there's 30 values. Between 2 and 2.5, there's 40 values. So if we were to do the cumulative frequency and keep track of how much frequency we've got up to that point, well, in the first category, we've got 25 things between here and here. So there's 25. Now, by 2, we've got everything in this group and everything in this group. So the next value would be 25 plus the 30, and we're going to get 55. Brilliant. And if you could tell me what would be in the next one, that would be superb. So it's now a running total. So now we're saying, right, up to 2.5, everything in here, here, and in here gets accounted for. So you're basically taking the previous value, excellent, very well done, the 55 you've counted so far, and adding the 40 that we've just added to that. And that's going to make 95. Well done. And then the next one, everything up to and including 3, will be this 95 plus the additional 45 in this category, in this class or interval. So that's going to take us to 140. And then 140 plus another 40 is 180. And then finally, 180 plus this 20 takes us to 200. And hopefully we realize that in the final group, this is what we call our total frequency. We've got everything accounted for. So hopefully that's nice and clear, but we're going to see where this is going. Who recognizes this? It looks like some people have seen this before. Excellent. So a cumulative frequency, the best way to think of it is like an accumulation. You're kind of gaining everything all together. So by the end of it, you've accounted for all the values. There's 200 bits of data all the way from 0 to 8. And I've kept a running total of the groups as they increase. So when we look at what this is as a graph, a cumulative frequency graph plots basically the upper bound, Yes, we do. So we're going to look at plotting it. The upper bound of each set and that is important, against the cumulative frequency of that set. Cumulative frequency of that set. So this is a nice example to look at. So for example, what we have here is we have the cumulative frequency on the y-axis there, the running sort of frequency. And what we have is on the axis at the bottom here, we have, 2 for up to 8. And so what we're going to do is we're going to plot where it is at each stage. So at the end of the first group, at 1, how high is it? It's up at 25. So I'm going to plot this at 125, which is here. Okay, so that's that value there. The next value we're going to plot at the end point of this interval, which is at 2. And at 2, it's up at 55, which would be somewhere around here. Then at 2.5, it's up at 95, which would be up here. So it rises quite quickly there. Can everyone see what I'm doing? Does this make sense? Are we all happy with this? No, brilliant. I'm really glad you've said that. It's not the midpoint for a cumulative frequency. It is very specifically the end point, the upper bound, but brilliant for pointing that out. The midpoint is for something called the frequency polygon, which, you might have seen at GCSE as well. That is the midpoint we use for that. But for the cumulative frequency, we have to use the end point because it's everything up to and including the end of that group. Because we don't know how everything's spread out in that interval, but I do definitely know, but by the end of 2.5, I've accounted for 95 things. So it's actually very important that you use the endpoint. But that was a super question, and a really important point to stress. We have to use the upper bound of each group to plot the point, which we don't want to confuse with frequency polygons where you would use the midpoint. Okay, brilliant. No, that's really good. So next one, we're going to plot at 3, 140, because we know that by 3, we have accounted for 140 bits of data. However, they're spread out within that category. By the end of that group, there's been 140 things. Then by the time we get to 5, it's up at 180, which will be around here. There we go. And then at 8, it's up at 200. Okay, and so as a polygon, how we're going to draw it, as a graph, we're going to try and draw it through those points, and it typically is sort of an S shape looking thing. Let's try that again. Try and get it going through all the points nicely. And so what we can do from there is we can actually use what we've done to answer questions as a follow-up. And this process is technically interpolating because we've got something to work off of and discover values for. So if I said, right, if I was to look at, like, for example, when x is 3.5, which is here, and I wanted to know roughly how many people or how many things are less than 3.5, well, what I can do is I can read that across depending on how I've drawn the graph. Let's have a little look. Have I drawn that accurately? Yeah, so if I read that across, I'd say for 150 people or less. Okay, so X would be cool. Brilliant, and we're going to explore this a bit more now. So going forwards, just give me a little checkpoint on how you feel with that. For some people, it might be that you've seen this before, you're very comfortable with it. Just a 1, 2, or a 3 to give me an indication would be great. And then what we're going to do is we're going to look at some exam style questions and then take this topic of data a little bit further and look at again how it comes up in A-level exams. So a 1, 2, or a 3 in the chat if you can, that would indicate how you find this sort of stuff. Thanks again for the comments and questions and answers in the chat. It's been really useful and it's good to kind of get that feedback from people. So do let me know. I'm going to move on though, so feel free to put that in. And then let's look at this exam question. So it says the temperature of a supermarket fridge is regularly checked to ensure that it is working correctly. Over a period of 3 months, the temperature measured in degrees Celsius, excellent, thanks guys, I'm just keeping an eye on the chat as well, is checked 600 times. These temperatures are displayed in the cumulative frequency diagram below. And notice it is that sort of S shape. So what we're going to do is we can use this to sort of complete the table. Now, what we've got is if we sort of look at some key points, remember, as we just mentioned, it's really important that we look at the endpoints. So as we can see at 4.2, it should be up at 243. Oh, sorry, yeah. It should be up at 4.2. Let's double check that. Oh, no. So sorry. The individual frequency is here. So we've got to reconstruct what the normal frequency is. So this is a little bit more involved. So because this is cumulative frequency, but this is just normal frequency, we need to look at what the actual frequencies are doing. So the way to work this one back is that if we look at this first group at 3.4, if we look at where it is, it's there, and that value is 25. Now that can actually go straight into the table because it's the first value. The next value at 3.8, if we have a little look at it, is up at 150. Now, there's not 150 going in here because this is the cumulative frequency. Can anyone work out if the cumulative frequency is 150, but we've already got 25 in the group before? What have we added in this next group to get us from here to here? So from here, if we do 150 minus 25, can everyone see that that next category must have 125 in it? Because its cumulative frequency is 150. And then likewise, if we keep going, so the next two bits are done for us. And we know that by 4.6, in that group, there's 157. Now in total, this is 600, the total frequency, okay? So what we can do is we can take off everything we've added up to that point. So if we add this, 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 and this, and take that away from 600, then we would get 50, which must be the amount left in here, okay? Or if we think of it from 4.6, that's up at 550, so we know that in that last category, there's 50. So this is quite a nice exam question to look at, and hopefully that makes sense to everyone. But what was weird about this question is seeing that it has a cumulative frequency graph, but it's also got a normal frequency table. So we're kind of having to do the backwards work here. So that was really good. And hopefully you guys followed that okay, because we're going to look at another sort of similar one. And then we're going to move on to looking at percentiles. So I'm going to just push this on now, but do feel free to ask any questions and continue to share any answers in the chat. That's great. Here we go. So this one here, the heating quality of the coal in a sample of 50 sacks is measured in suitable units. The data are summarized below. Okay, so if we think about what's going on here, now at 9.3, the end point, we've got 5. At 9.5, can anyone tell me what the cumulative frequency would be? What would it be for that one? Now, I am going to have to draw an axis on here in a minute, but let me know. So you're adding the two together, and hopefully we're happy that that's 12. Okay, excellent. And then what we'll do it for 9.7, 9.9, and 10.1. Okay, so for 9.7, I'm going to do the 12 plus the 15. And then we're going to take that value and plus the 16. And then we're going to take that value and then that's the 50 that it should add up to. Good. So if we now start drawing this, I'm going to get the, I think a sensible interval would be use 16. If we go up in 4s. Okay. And then along here, if we go from 9, maybe 9.2. Okay, now this starts at 9.1, which is here. Then at 9.3, we're plotting it up at 5, which would be about there. Then at 9.5, we're plotting it up at 12, which would be here. At 9.7, we're plotting it up at 27, which should be somewhere about here. And then at 9.9, we're plotting it at 43. So 43 is going to be about here. And then at 10.1, we're plotting it up at 50. So if we now draw the cumulative frequency graph through that, That's good, hopefully nice and neat. And then we can go from there to whatever they want us to work out. Great, so I'm going to keep going and we're going to move on to the next little subtopic. So we're going to look at percentiles now and how we can use these graphs to work out things like percentiles. So here we go. We can estimate the percentiles of group data by determining, and do feel free to ask any questions if anything's unclear. So by determining the cumulative frequency, I'm going to just abbreviate that to CF, at the percentile that we're looking at. And finding, so we'll do this example in a minute, and finding the corresponding point. Cool. On the line of best fit on the cumulative frequency graph. So I think this will make more sense when we go through an example, hopefully here. So for this one here, what we've got is we've got 200 bits of data. And so if we wanted the median, hopefully everyone's happy that that would just be at the 100th value. You'd go across and then you'd read it down. And you try to determine what that would be. And in that case, we can say that the median is approximately 2.6. So you're reading off the value of the x-axis. Good, so hopefully that's nice and clear. And then the first quartile, well, if the median is halfway, it's out of 200. First quartile, quite nicely, is 50. If we go along to there and read it down, I think that one is going to be sort of value of 1.8. And then in a similar way, the third quartile, again, we're just sort of reading it off. So I'm sure you guys are hopefully familiar with this sort of thing from GCSE. Let's say 2.8. And then the 90th percentile would be sort of up at the 180th value. So 180 up here. Okay, and if we read that down, hopefully we're happy, that's about 5. Okay, brilliant. So what we've done is that the nth percentile is at like n out of the total cumulative frequency, and then we've times it by 100. So we've turned it into a percent instead of in quarters. So that was really good. We'll see a little bit more of this going forward. Now, another really important point, and I've seen this in quite a few statistics A-level mock exams, but also specimens and kind of papers that relate to the real exam. They could ask you to do this, is to use a box plot and a cumulative frequency together. So a box plot of group data can be drawn using the estimated quartiles. And just think, why is it estimated? When we use a cumulative frequency, why is it estimated? And they can ask you to comment on that. What is estimated? Even though we've done it a very specific way, think about the data we've got. We don't know the raw data. So we are kind of estimating when we use the graph. And the maximum and minimum values of the plot are basically the start and end of the graph. Okay. Okay, cool. So let's have a little look. Now, I'll put that here. So what I'm doing is I'm using, hopefully we can see this. I'm sure some of you guys are familiar with this stuff, but using the actual estimated values from the cumulative frequency to basically give us those values on the box plot. And then drawing the box plot in place. That's it. So that should hopefully be sort of fairly recognizable. But what it will allow us to do is the point of a box plot sort of shows us the kind of key information, but also the middle 50% of the data. So it gives us an idea of how the data is behaving and how it works around the middle, where the median is. So it is really important that we can kind of sort of see the shape of the data almost. So this is really good. Now, just give me an indication if you want to just give me a 1, 2, or a 3. And then we're going to, again, do some exam style questions of this to check that we're happy. So let me know in the chat if you've got any questions or you want me to backtrack at all, or you want to ask anything specifically about this part of the statistics side of the A level, please do in the chat and I'll do my best to answer that. But that this is, again, a topic that, as I've said, will come up on all the different boards. Is really important that you absolutely understand and are happy with. And you will be asked follow-up comment questions as well. So it's an important one to be really rigorous and clear about. So yeah, if you give me a 1, 2, or a 3, let me know how you feel with that. Thank you again to those commenting and asking questions all the way throughout. That's been brilliant. I'm going to keep going, but just let me know 1, 2, or 3 on how you feel with this content. So here we go. Let's look at this question here. So we've got the examination marks obtained by 1,200 candidates are illustrated on the cumulative frequency graph. And the data points are joined by a smooth curve. So it says use the curve to estimate the interquartile range of marks and X if 40% of the candidates scored more than X marks. So I think this is a really good exam style question to look at. First of all, what do I mean by the interquartile range? What am I going to have to do here? So from this graph, how can I find the interquartile range? What would I need to do first of all? We know the total frequency. We can see that on here, 1,200, 1,200. How do I find the IQR, the interquartile range from this thing here? So the interquartile range means the difference between a quarter of the way through the data and 3/4 of the way through the data. Notice it is an estimate, but I'm going to need to use the graph to do this. So first of all, if I start looking for the quartiles, well, if the total frequency is 1,200, what is the first quartile? Where would that appear? So we effectively want to break this data, this group data, into 4 chunks. So if I divide 1,200 by 4, now I don't need to do the whole add 1 thing because it's grouped continuous data. Hopefully we're happy that it's going to be in regular intervals of 300. So the first quartile will be if I read along from 300. I'm going to try and do this as carefully as I can. So the first quartile, sometimes denoted as Q1, is going to be, so we're going to do 1,200 over 4. And I'm saying that that's given me the 300th value, 300th term. And that's approximately 45. Is everyone okay with that? Does that make sense? Apologies, my line was a bit wobbly there. Try and do that again. Does that make sense? Is that okay? So that's the first quartile. Now we're trying to find the interquartile range. So I could find the second quartile, the median, but the one I really want is the third quartile, Q3. So this would be 3/4 of 1,200. So this is now the 900th term. So if I go and look for that, Again, I'm going to try and do this really steadily. I'm going to read that down. Okay, that's roughly coming out, let's say approximately 69 mark, around the sort of 69 mark. And then IQR, the interquartile range, then the actual answer to this question, the difference between that and that would be 24. So that's the interquartile range. That's how much spread there is between the middle 50% of the data. So that's what we found. We found the interquartile range. Now, I want to talk carefully about the second part here, the second bit of question, which is asking us to find X if 40% of the candidates scored more than X marks. The reason why this kind of question is really important is I relate it to a little bit of a more involved part of the statistics course, which is called hypothesis testing and tails. And there's a little bit of confusion sometimes when you're doing an upper tail or a boundary onwards from something that's cumulative. I don't know if you guys have come across this before, but trying to find an upper tail of an accumulation of stuff can be quite complicated. So if I want the value of X, if 40% of the candidates score more than X, what is another way of phrasing that? How else can we think of that? So if there's a boundary value X, whereby 40% of the candidates scored more than X marks. The thing is, with something cumulative, we're not dealing with above, we're sort of dealing with everything below it. So if we were to rephrase this, if we were to say, right, what's the same as the value that 40% is more than that? It's the same point or the same position where 60% is below it. So this is actually a really like another way of saying the 60th percentile, because what we're basically saying here is if 40% of the marks are above that value, 60% of the marks are below that value. So we're saying we want to be 60% of the way through the data. So we're actually looking for the 60th percentile for these 1,200 candidates. So we're looking for the 60th percentile, and the way to do that is we're going to do 60 100ths, oh, not thousandths, of, and that is going to be 720th value. So if I do that, I'll read that across carefully. It's coming out at about 63. So what we're saying is that this value 63, there's approximately, well, what we would expect, 40% of candidates scored more than that. So 60% of candidates scored that value or less. And that's what we've found from this question. So that was a really good one, because I actually think that's very in the style of the exams that we've seen stuff like this a lot, where they'll phrase it in a strange way, but still expect you to sort of know this means the 60th percentile. Because 60% of the way through, at that position, 60% will be that value or less, but 40% will be the above tail, will have sort of superseded that. Okay. So I'm going to move on, but do feel free to ask and check anything as we go. What I'm going to do now is another really good follow-up question on this sort of thing. Because again, we've got to look for those quirky kind of questions in the exams that catch people out. So for example, for this one here, the question says, use the curve to estimate the number of candidates who scored more than 68 marks. Okay, so this is just flipping the scenario the other way round. And what we're going to do for this one is same sort of thing. We're going to go to 68, read up to the line, read it across. And we need to, again, whoops, a bit wobbly, be very careful here in how we interpret what the question has asked us to do. So the value we've got on there is 860. Now, what we've actually found is that 860 is the number of candidates who actually scored less than 68. Okay. So if we know there's 1,200 candidates, the amount that scored more must be this. Does that make sense? Again, very common that they'll do it that sort of way round. Right, now this next bit is really interesting because it's a weird sort of question to follow up with. So it is subsequently discovered that the candidates' marks in the range from 35 to 55 were evenly distributed. That is roughly equal numbers of candidates scored 35, 36, 37, and so on, all the way up to 55. Then it says, what does this information suggest about the estimate to the interquartile range found in part I? This is a really brilliant question to look at, because this sort of thing, people are really unsure on how to interpolate graphically. So in part I, we found out an estimate for the interquartile range. Now, if we're being told that it was evenly distributed between 35 and 55, that actually means that we would say it's got a sort of nice consistent gradient. Whoops. And so that bit should actually be a straight line, because if it was evenly distributed, it's increasing at the same rate. So what this would mean is the first quartile, if we look at 300 and we read across, we would hit this line first at 41. Okay, now earlier when we used that, we hit the line a bit later on at 45. So we need to think about what effect this will have on the interquartile range. So what this means is the first quartile we calculated was actually greater than the true value. So in light of this new information, we can see that earlier when we calculated the lower quartile, we kind of got a value bigger. So it was greater than the true value. So what effect this will have is that this means that really the interquartile range we calculated is actually probably smaller than the true interquartile range. And I will clarify that. So earlier, when we thought that those values were following this curve shape, we discovered that the first quartile was coming out about 45. Now, when we look at this more carefully, this sort of looks at like 41 or 42, which is less. So that means that if we were to recalculate the interquartile range, it would be bigger. So this one is probably, sorry, I missed out the key word there, it's probably smaller than the true interquartile range. So this is a really interesting question to look at, because it does catch people off guard in the exams, in that they're telling you that the shape of the graph is actually not very good for these values. And instead, from here to here, would be modeled better with a straight line. And if we were to now use that line to re-look at what we've calculated, like the interquartile range, we know that we'd hit that line before we hit the curve. So the interquartile range, so the lower quartile would actually be a lower value, meaning that the interquartile range would be a bigger difference. So it's telling us that the one we calculated earlier was probably smaller than the true value. So you have got to read the wording of these questions really carefully, but annotating things on there like that to see what's actually happened is really important. So that was good. So I think we'll just do a couple more follow-up exam questions on this, and again, look at the kind of comment ones. So the birth weights of 200 lambs from crossbred sheep are illustrated by the cumulative frequency diagram below. So it says, estimate the percentage of lambs with birth weight over 6 kilograms. So let's again do that. Let's look at 6 kilograms and let's read up and across. And do feel free to work ahead of me. I know it's perhaps a tricky one to see, but let me know in the chat if you can see what that would be. Now, reading it off, lambs below 6 kg would be approximately 160. So in terms of how many above it, given that we're dealing with 200 lambs, now it does say estimate the percentage. Okay, so that would be 40 out of 200. Okay. Now the next one, estimate the median and interquartile range. So let's have a little look. And again, straight from the diagram, it's out of 200. So the median, we're going to go across at 100, read it down, and it looks like 5.2 kg. The first quartile is going to be at 50. Read that down, and that looks like that's at 4.2. Sorry, not the second quartile, the upper quartile. The third quartile. The second quartile is the median, isn't it? So the third quartile will be up at 150. It's going to be very close to that value there. That's nice to read down. I think for that one, we're going to get 5.8. So that's going to tell us that the interquartile range will be equal to 5.8 minus 4.2. So it's spread out across 1.6 kilograms. Okay, that was really good. So that's, again, kind of classic using and reading off and estimating. Now, what we're going to do is on the next one, we're going to be asked to do a comparison, which, again, some of you might have seen at GCSE, but there's some key things that the question is looking for in the answer. So the box and whisker plot shows the birth weights of 100 lambs from Welsh mountain sheep. So on the previous one, we were dealing with crossbred sheep, and here we're dealing with Welsh mountain sheep. So if I just write the information down that we found in the previous slide about the crossbred sheep, we had a median of 5.2. We had an IQR, an interquartile range of 1.6. We had a maximum value of 8.8. We had a minimum value of, was it 2? Yeah. And so what we've got is when we want to compare the central tendencies and variations, we're going to look at the bits of information that we've got here. Okay, so we've got that for the Welsh mountain sheep there. And what we can do is also find the interquartile range for that by doing 3.9 minus 3.1, which equals 0.8. Okay, so the mountain sheep have a smaller median weight than the crossbred sheep. So it is literally just a comparison. So we could say, so are lighter on average, putting it back in the context, lighter on average. And then the other thing we're going to compare is that they also have a smaller range. And this sort of being able to compare the variance or the spread and the measure of central tendency is really important. So you've kind of discovered, you've talked about or commented on two very different things. So they also have a smaller range and interquartile range. Of weights. So that's to do with the spread. Yep, sorry, let me just try and make it a little bit clearer. Smaller range interquartile range of weights. Yeah, do let me know if there's any bits that are unclear and you want me to rewrite. So I'll reread that. So it says the mountain have a smaller median bred sheep, so are lighter on average, and they also have a smaller range and interquartile range of weights. Okay, so that's the crossbred sheep information there. And that's the information we had got for the Welsh mountain sheep from there. And then we're just doing a comparison. Okay, so do let me know if there's anything you need me to clarify still. But hopefully the main thing that we need to know for when we're doing a comparison is that we compare, even if they don't tell us, we compare measures of location and central tendency, like the median, and we also compare measures of spread, like the range and the interquartile range. That is really important for doing comparisons because you can't just comment on where the middle is or the median or the average, because that doesn't give you the full picture. You also have to comment on how the data is spread out around that. And that was the point we were making here. Good. So hopefully from what we've done there, we've looked at understanding cumulative frequency with group data specifically, because that's very likely how it's going to come up. We've also used the graphs to estimate percentiles of group data. And this is something you could be asked to comment on. These comment questions are really important. And then from the group data, we've also gone and done a kind of spin-off of drawing box plots, which was really important as well. So if there's anything you want me to go back to, any other questions you have on any of that or kind of side topics to this, adjacent topics, please let me know. What I'm also going to do is quickly talk about some of the bits we've got through Snap Revise that will hopefully help you with your revision and tailoring how you revise to make sure it fits the course. But if you have got any questions, I can still see the chat. Please feel free to ask those in the comments. I'm going to just stop sharing that screen now, unless anyone wants me to go back over anything. That'll be fine. I'm just going to share the following screen. So hopefully you can see this. So what we've got here is the maths course on Snap Revise. And if you haven't explored this platform before, there's loads on here, so definitely check it out. On Snap Revise, we have the web classes, loads of web classes happening every week. So you have year 12 and year 13 web class, and then a drop-in as well twice a week to ask any questions on mechanics, statistics, or pure maths. And you can see those, and you can even get kind of a catalogue of previous web classes. So if that's something you're interested in doing, definitely check out Snap Revise, and you can kind of sign up and join. If you're enjoying the web classes and find it useful, you'll be able to see that actually the whole course is covered throughout the year in normally a time frame that matches what you're doing in school. And the drop-in sessions, we use those to cover any content you're working through or need help with. But there's loads of other resources on here as well. So not just the web classes, but there's diagnostic quizzes, really beautifully clear notes, and resources for revision as well, practice papers. Every single part of the course is really broken down and designed to be tailored to what you've done in school. So this is really kind of crucial stuff, because I think for those that are practicing now and looking for resources for improving their exam technique, it can be quite difficult to find resources that are tailored towards the new A-level, specifically for the different exam boards. And the exam packs, the revision guides, and the videos and web classes are all really geared up for kind of maximizing how you can perform in an exam situation. So hopefully you're finding these YouTube sessions useful, but if you haven't checked out the website yet for Snap Revise, please do. As I said, there are loads of web classes happening all the time. There's loads of extra resources on there. And the key thing is it is really tailored to the courses you're doing. So every single spec point, every single part of the specification has been looked at really carefully and meticulously in the design of all of this content. So well done today. I hope that was useful. And thanks again for all the brilliant comments and questions in the chat. A few really key things clarified there. So even if that was a topic you've done before, and you've seen this part of statistics and you're comfortable with it, that's brilliant. But I think the key thing to remember is, particularly with the statistics, it's very specific in how they mark the exams. So you do need to know what to look out for in the question. But really, really well done. And again, if you have any questions for me, if there's anything you want to check, do let us know. There'll be more web classes running. And as I said, do check out Snap Revise if you haven't already, or you haven't seen before some of the stuff that's available there. But yeah, as I said, we're covering mechanics, statistics, and the pure parts of the course fully throughout the year. And yeah, the web classes are very much the same style as you've been part of today. So do check that out. Thank you again for taking the time, especially those joining live on a Sunday, to work through this content. I hope you're all keeping well and have a really good rest of the weekend. And thanks again for all the comments and questions throughout. Well done, guys. Take care. I'm going to stop that there, but great work, and keep safe, and hopefully see you at another web class soon. Cool. Well done. Take care. Bye.